Algebra 1 kids, this is Dr. Callahan with Week 9 Wednesday. How are you guys doing? Go ahead and pause the video and answer the following 3 questions for your warm-up log. Keep in mind your warm-up log is going to be due on Week 9 Friday, so it's going to be due this Friday, and it is also worth 300 points, so I highly suggest that you make sure everything is filled out and you're ready to go. All right, let's go ahead and create the assignment for Algebra 2 for Week 9 Wednesday. So keep in mind that all of your assignment is always going to be on MS Teams. On the hyper days, it is imperative that you check in with me because if I don't see you viewing the assignment, then to me it's saying that you are not present. But in order to receive the grade for today, you would have to upload your assignment with a photo of your work. So this is for Algebra 1, Semester 2. And today we're going to go ahead and talk about modeling with quadratics. Your instructions are the same as always. Make sure you watch the video in its entirety. Make sure you pause the video and complete the assignment and upload it. You need to check in with me today, Wednesday, by 8:34 a.m. to ensure that you are going to be marked present. And as always, your assignment needs to be uploaded by 3 p.m. Okay, let's go ahead and get back to the assignment then. So let's go ahead and take a look at the breakdown of what we're going to be doing today. This is kind of what we're going to be looking at. I'm going to go over example 1, which you're just going to be paying attention. My notes is going to be on modeling quadratics, word problems. You will need to have 2 colors for today. Example 2, you try a problem with a ball toss, and then example 3 with a dolphin problem. I do have a quizzes that you guys can go ahead and access and work on in addition to that. Okay, so for this first example, I want you guys to do is go ahead and just pay attention as I go through this. So let's go ahead and take a look at the questions here, okay? So use the graph to the right. It shows the height and age of a small rocket after t second after it is launched. So looking at this, if this is your equation, you know your A is a -16, your B is 128, and your C is 0, okay? A, B, and C. And then from there, you can see that how long is a rocket in the air? Well, it starts from 0 because the bottom x-axis shows you the time in seconds, goes all the way up to the maximum, and then falls down. So the entire duration is about 8 seconds long. What is the greatest height the rocket reaches? Well, it goes all the way up to the max right here. The y-axis represents your feet of how far and how tall the rocket reaches. And so it looks like it's right around 260 feet is kind of what I would say it is, okay? And how high is a rocket after 1 second? At 1 second, it looks like it's about 100 feet. After 6 seconds, it is right about 190 feet. And then, of course, using the equation, exactly what is the value of the height after 2 seconds? So if t equals 2, I could look at the graph, and it looks like maybe it's 190 feet. But to make sure, we don't just want to assume it's 190 because when you're launching a rocket, you want to be absolutely precise to the thousandth decimal. So let's put in 2. Whenever you see a t here, you replace it with the 4. So, or sorry, 2. 2 times 2 is 4. Plus 128 times 2 right here. So with your calculators, once you go ahead and multiply them together, -64 plus 256 gives you 192 feet to be exact. The range and domain, this graph, domain means left to right. So as I'm starting from the left side, going over to the right side, it is at 0 to 8. Looking at the range of this graph, it's from 0 all the way up to the maximum of 260. When is the interval increasing and decreasing? Well, from 0 to 4, it is a positive slope, so that's increasing. And then from 4 to 8 is a negative slope, so that is decreasing. So we actually did go over this at one point, but today I just need you guys to pay attention to that. Now that we have done this, I'm going to have you guys try this one on your own. So turn over to this part here. All right, so looking at this, it says a ball is thrown in the air. The path of the ball is represented by this equation. We're actually the equation to the accompanying grid. Okay, so then looking at this part right here, you have A, which is going to be a -1, B, which is 8, and C, which is 0. Now remember, if you want to know the vertex of this grid, it's a -b over 2a, which is equal to x. So I have a -8 over 2 times -1 equals x, which is a -8 divided by a -2, which is a -4, okay? So that's what the x is going to be at -4. +4, just kidding, +4. But then I need to know what the y value is. And so what do I do with that? Well, the height of this is going to be -t squared. So we replace that -t with a +4 squared plus 8 times +4. We have a -16 plus 32, which is going to give you a y value of 16. So your vertex in this situation is going to be at 4, 16. And because you have a -t squared, you know it's going to be a sad face, because as you guys know, a +t squared is going to be a happy face. So let's go with this, okay? So here it's t in seconds. So 1, 2, 3, 4, up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And what is the maximum height of the ball? Well, given the fact that your vertex is right here at 4, 16. That your height is going to be 16 feet. What is the amount of time that the ball is above 7 meters? So for this one, you have y equals 7. So you have 7 equals -t squared plus 8t. My goal here is to solve for t. So I'm going to have a negative. Let's go ahead and factor out a t. So I have a -t plus 8. So t equals 7. And -t plus 8 equals 7. -t equals -1. T equals 1. So what that means is that when t is at 7, so 1, 2, 3, 4, 5, 6, 7, this is going to be at the height of the ball is going to be above 7 meters, okay? And then also it's going to be above 7 meters when t equals 1. So I should really redraw this a little bit. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right there. And now 1 is also going to be at 7. So redrawing this, I should have this piece that looks like this. There we go. So I will say t equals 7 and 1 second. All right, so looking at the next one over here, it says a swim team performs a dive from a 14-feet pole. I'm actually going to modify this a little bit so that it's a little bit easier for us to see. Okay, so a swim team member dives from a 14 feet path of a springboard. The parabola below shows the path. What is the axis of symmetry? Remember the word symmetry means that it is like symmetrical. So like, for example, if this is a heart, that line will be the axis of symmetry on that heart. So if I look at my axis of symmetry here, it will be this axis right here, which is at 3 feet. Find the height after 6 seconds. So if I look at 6 seconds, and her height in this situation is going to be at 14 feet. All right, so now that I have demonstrated 2 of them, let's go ahead and try this one right here. So what you're going to do is, this graph of a quadratic formula is called a blank, which is a blank shaped graph. How do you think the picture of the dolphin below is connected to the quadratic equation of the parabola? So what I want you guys to do is I want you to draw an x-axis across the top of the waterline of the dolphin. Draw the y-axis at the beginning of the dolphin jumps. With your pencil, trace a path of the dolphin jumps. Label the vertex. Predict what a real-life vertex could be for a dolphin by answering the following questions. How long does it take for a dolphin to jump out of the water? Follow its path and back in blank seconds or minutes. How high do you think the dolphin can jump? In inches or feet? Predict the vertex, tell if there is a maximum or a minimum, and label the x-intercepts. What does each intercept mean? So as you can see here, I don't have any specific numbers because this is more of a creativity thing for you to go ahead and do. So with your rulers and then also your colored pencils, go ahead and draw the path of the dolphin as the dolphin is jumping. Alright, you guys, so if you are done with this, I am going to have you guys practice with this a little bit more. Now we are going to practice this on the quizzes. Alright, so I am going to go ahead and it is basically 12 questions. I'm going to go ahead and assign this as a homework so you can also do this at home. And you would just have to go to DrNataliaCallahan, answer the code 529-722-84. So once again, DrNataliaCallahan, answer code 529-722-84. Okay, next one I have you guys do is on a separate piece of paper. I would like you to go ahead and create a Venn diagram. We're going to create a Venn diagram comparing middle school and to high school. Okay, so like some of the things that I would think that looks like this is in middle school, everybody kind of just passed and you just got moved along. In high school, it's a little different because you have to gain your 22.5 credits. So using a Venn diagram, just drawing 2 overlapping circles, give me 4 things that are specific to middle school, 4 things that are very specific to high school, and then 2 things in between here. All right, so now what I'm gonna have you guys do is you're gonna go ahead and Google a few terms. You can Google self-factoring, you can Google quadratic equation, or you can Google completing the square, which are all 3 things under quadratics. So what I want you to do is Google one of those topics, give me the definition, draw a picture, use a Google image, that's totally fine. Show me examples with steps and bubble the answers where this apply in real life. Come up with a scenario. And that's it. Alright, you guys, as always, stay safe and healthy, and I will see you guys next time. Take care.